Dear students, in this video, we are going to discuss about the nature of the roots of the quadratic equation ax square plus bx plus c is equal to 0. Without finding the roots of the quadratic equation ax square plus bx plus c is equal to 0, we are going to know about the nature of its roots. Now let us try to observe the graph of y is equal to ax square plus bx plus c. Now our quadratic equation ax square plus bx plus c is equal to 0. That is, when the value of y is equal to 0, we'll get the roots of this quadratic equation. We know very well y will be 0 on x-axis. So the points of intersection of this curve with x-axis gives us the roots of the quadratic equation ax square plus bx plus c is equal to 0. Let us try to note down the values of a, b and c in this case. So let us write down the value of a. A is 1 here. B is equal to 0. You can see, children, 1x square plus 0x minus 2 is the equation of this graph right now. So when we are comparing and noting down the values of a, it is 1, the coefficient of x square. The coefficient of x is b, it is 0 right now. And the constant c is minus 2. Let us just observe the value of its discriminant. The discriminant of a quadratic equation ax square plus bx plus c is equal to 0 is given by b square minus 4ac. So when we calculate it, here in this case b is 0, 0 square minus 4 into a is 2 and c is minus 2, and when we calculate it, we got it as 16. So right now 16 is a positive value. Let us try to change the values of a, b and c and observe the value of the discriminant and the graph. Let us see, children. So when we are changing the values of a, you can observe, children. Observe the value of the discriminant here and the graph, right? So right now this is positive and the graph is intersecting at 2 points. The x-axis at 2 points. You can observe. Yes. Let us change the values of b and observe what is happening. Yes. Yes. Even now the graph intersects the x-axis at 2 distinct points. This curve intersects the x-axis at 2 distinct points. Yes, you can observe. And the discriminant value is positive. Let us change the values of c and observe what's happening. So even now, the value of the discriminant is positive and the graph intersects at 2 distinct points. Let us change the values of c. Yes, now the graph is not intersecting the x-axis. So is there any change in the value of the discriminant? Let us check. Yes, right now it is negative. The value of the discriminant is negative, and we notice that right now the curve do not intersect with x-axis. Let us observe few more cases. Is it every time? Now negative and not intersecting. Negative, positive, it intersects. Positive intersects at 2 points. Positive. Negative. You can observe, children. Now the graph is downwards. It is in third and fourth quadrants. You can observe here. And it is open downwards. and it's not intersecting, the curve is not intersecting x-axis, and you can observe that the value of the discriminant is minus 20, that is negative. Okay. Now observe children, the value of the discriminant here in this case is 0. So what is the change we observe here? The curve touches the x-axis at one point. You can just see here, it won't intersect, but it touches, it just have one point in common with x-axis. So let us take few more cases. Let me change this B as 6, and let us change the value of C also. Yes. What is the value of the discriminant right now? 0. So when the value of the discriminant is 0, we can observe that this curve is touching x-axis. That is, it has only one point in common. Let us take one more case and then we'll just see. Now when the value of B happens to be minus 6, again we got the discriminant as 0. So we can even notice now that it is touching x-axis at one point. So we have seen 3 different cases, children. When the discriminant is positive, we got case 1. When the discriminant value is positive, we got 2 distinct real roots. That is, we have roots, the real roots for this graph, and we observe that we have 2 points of intersection of this curve and x-axis when the discriminant is positive. When the discriminant is 0, you can observe that it has only touching at one point, and those 2 roots which are supposed to be there for a quadratic equation are equal. That's the reason you can see only one point here in common. Okay. And the final case, when the discriminant value is negative, that when the discriminant is negative, we do not have any real roots. There are no real roots. That's all for today, children.